This is a Semester 2 final exam review for Pre-Calculus Honors Part 1. I'm going to do problems similar to ones you're going to see on the final. However, there's some other things we have to talk about. We started the semester off studying trigonometry, and the big thing we need to come out of trigonometry knowing is the unit circle, because that unit circle got us through all of trigonometry and it got us through polar coordinates. So a couple things to remember. The unit circle is the circle of radius 1, and because it's radius 1, we can find the sine and cosine of special angles on the unit circle. Those are angles whose reference angle was 30, 45, or 60. And depending on what quadrant you were in, gave you different signs in front of your answer. So it may be positive, it may be negative. In quadrant 1, remember that both coordinates are positive. And the way we did this was we started with 30 degrees, which was pi over 6 radians. And if you aren't sure what the sine and cosine are, you can always go back to your 30, 60, 90 triangle. And that's how we originally did this. Here's your 30, 60, 90 triangle. And the way the ordered pairs are done is the first value is always cosine and the second value is sine. Think about it like this. It's always in alphabetical order. So the sine of 30 degrees is going to be 1/2, and the cosine is going to be the square root of 3 over 2, because the x's end up canceling. For 45 degrees, which was pi over 4 radians, you had to use your 45, 45, 90 triangle. And the 45, 45, 90 triangle is x, 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 the square root of 2. So for sine and cosine of 45 degrees, you end up with the same answer. And you can either tell me it's 1 over the square root of 2, or you can tell me it's square root of 2 over 2. Either one is acceptable. For 60 degrees, which was pi over 3 radians, and I know you want 30 degrees to be pi over 3, but it's not. For 60 degrees, the sine, or the cosine, we want to start with cosine, was, I already messed this up, didn't I? Let's go back here. Sorry. The cosine was square root of 3 over 2. And the sine was 1/2. So for 60 degrees, the cosine is 1/2, and the sine is square root of 3 over 2. And then at 0 degrees, which is 0 radians, it's 1 for the cosine and 0 for the sine. And at 90 degrees, which is pi over 2 radians, it was 0 for cosine and 1 for sine. Well, now when you get into quadrant 2, the signs change. So in quadrant 2, x is negative, but y is positive. So 120 degrees, its reference angle is 60 degrees. Remember that you find a reference angle by finding the number of degrees between the angle and the x-axis. So if I'm at 120 degrees, which is 2 pi over 3 radians, I would do 180 minus 120. All the first quadrant angles are already reference angles, because a reference angle is always between 0 and 90 degrees. Then 135 degrees, whose reference angle is 45 degrees, is 3 pi over 4. And 150 degrees, whose reference angle is 30 degrees, and whose radian measurement is 5 pi over 6. Their answers will be the same as their reference angle counterparts in the first quadrant, except that the cosines will all be negative, and the sines will be positive. And at 180 degrees, which is pi, you'll be at negative 1, 0. And then you continue around the unit circle the same way. Remember, there's kind of a pattern to how this works. The way that I showed you guys was, this is pi over 6. This one was 2 pi over 6, which reduced to pi over 3. 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. And then we did the same thing for our 45 degree angles. We had pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So like I know down here, it's going to be 5 pi over 4. And then this one is 6 pi over 4, which reduces to 3 pi over 2. So now with that in mind, we're ready to go and talk about some of the problems you'll run into on the final exam. All right, first problem, let's find one positive and one negative coterminal angle. The problem on the final will actually say which angle is not coterminal with a particular angle, but the process is the same. When you want to find coterminal angles, if you think about where negative 50 degrees is down here in quadrant 4. A coterminal angle is one such that if you take that ray and you rotate it around in a complete circle and stop in the exact same place you started at, you're going to have a new angle measurement, but the ray's in the same place. So those two angles are called coterminal. So one way of finding a coterminal angle when you're working in degrees is to add 360 and to subtract 360. That's going around in a circle in two opposite directions. Let's see, did I do this right? 4 times, yes. So one way is going clockwise and the other one's going counterclockwise. This one's clockwise and this one is counterclockwise. Well, how do I do this if I'm working in radians? Well, 360 degrees is 2 pi, so you can do plus 2 pi. Which is going to be, let's see, 2 pi plus 6 pi, which is 8 pi over 3. I did the little trick for adding fractions with unlike denominators, so it's 2 pi plus 6 pi, which is 8 pi all over 3. And then the other one's going to be 2 pi over 3 minus 2 pi. And you can still do this little process, you just have to be careful about where you start. You always start down in the lower right-hand corner. So this one's going to be 2 pi minus 6 pi, which is negative 4 pi, over 3. And those are your coterminal angles. Since this is a multiple choice test, remember that the way that I show you how to do the problem in the video isn't necessarily applicable, only because if you do this problem in your calculator, the tangent and the inverse cosine of square root of 3 over 2, you're going to get a decimal answer. But the multiple choice answers are not going to be in decimal form. They're going to be exact. Well, that's really easy to deal with. Just change all the multiple choice answers into decimals and find out which one matches the decimal you got on your calculator. But the actual algebraic process for this problem, first you would start on the inside of the parentheses. The inverse cosine of square root of 3 over 2 is the same thing as saying the cosine of some angle is square root of 3 over 2. So if you draw yourself a right triangle and call one of the angles theta, I'll call that one theta, then the cosine must be square root of 3 and 2, which means that the opposite side must be 1. And then to find the tangent of that angle, you would do opposite over adjacent. So it'd be 1 over the square root of 3, or you could tell me it's square root of 3 over 3. And even though this answer would be a decimal on your calculator, you could have found it in the multiple choice by changing all the multiple choice answers into decimals, and then you'd find the right answer. Or you can do it the algebraic way. I don't care. Number 3, evaluate the cosine of theta equals 1 for all values of theta. That means that you're going to start with, well, okay, so the cosine of theta equals 1. Theta is the inverse cosine of 1. If you shove that in your calculator, you're going to find out that cosine is 1 at 0 degrees. But that's just for one rotation. If you just look at angles between 0 and 360, the answer is 0. But if you want them for all values of theta, as long as you remember that the period of a cosine graph is 2 pi, so this will repeat itself every 2 pi. All you have to do is add 2 pi k at the end of your answer. This is true for both cosine and sine. Tangent, however, repeats every 1 pi. So if this were a tangent problem, for example, if I said the tangent of theta is equal to 1, theta would be 45 degrees, or pi over 4, depending on what we wanted the answer to be in radians or degrees. And then you would just tack on a plus, plus pi k, because the period is only 1 pi k. And just a reminder, because the final will go back and forth between using degrees and radians, remember that if you want to change degrees into radians, you multiply by pi over 180, and then you reduce this fraction. And if you have something in radians and you want to change it back into degrees, just replace the pi with 180. I believe that's 120 degrees. Yep. You can multiply by 180 over pi, but look what happens. You end up just doing 2 times 180. Pi is the same as 180, which is why I just replaced it. Here's another problem that requires our right triangle trigonometry. If the cosine of theta is equal to negative square root of 3 over 2, and theta lies in quadrant 3, find the cosecant of theta. Quick review. Sine is the reciprocal of cosecant. Cosine is the reciprocal of secant. And tangent is the reciprocal of cotangent. So what I would do is I would start by drawing a right triangle in quadrant 3. Remember that when you draw your right triangles in a quadrant, your hypotenuse will always be the ray that goes out into the quadrant. One side of the triangle should be on the x-axis and the other leg should be parallel to the y-axis. Theta is always the angle closest to the origin. So now the cosine is negative square root of 3 over 2. So here's my adjacent and here's my hypotenuse. My hypotenuse is never negative. That's how I knew that the adjacent side was negative. Well, I gave you an easy one because the other side is going to be 1. This is yet 1, 2, and square root of 3. But we're in quadrant 3. In quadrant 3, both x and y are negative. So even though if you use the quadratic formula, the Pythagorean theorem, if you use the Pythagorean theorem to solve for the missing side, you would have found out it was positive 1. You have to ask yourself what quadrant you're working in so you know if your answer should be positive or negative. Or the other thing you can do is you can ask yourself, well, what sign should the final answer have? If you remember, all students take calculus. The only thing positive in quadrant 3 is tangent and cotangent. Everything else is negative. So cosecant is going to be negative. So now what I would do is I would find the sine of theta, and the sine of theta is going to be negative 1 over 2. So the cosecant has to be its reciprocal, which is negative 2 over 1. There is something that shows up on the final that we didn't really talk so much about. I want to go back to your general 30, 60, 90 triangle, where this is 1, this is the square root of 3, and this is 2. Remember when we're dealing with the sine, so the sine of 30 is 1/2, and the cosine of 30 is square root of 3 over 2. If I instead focus on the 60-degree angle, the sine is the square root of 3 over 2, and the cosine is 1/2. So there is this definition that says that the sine of 90 degrees minus theta is the same as the cosine of theta. So in other words, if I put in the sine of 30 degrees, that's going to be the same thing as the cosine of 90. I'm sorry, let's try that again. If I put in the sine, if I would do the sine of 30 degrees, it's going to be the same as the cosine of 60, because 90 minus 30 is 60. Or if I find the sine of 60 degrees, that's going to be the same thing as the cosine of 30, because 90 minus 60 is 30. Here is another right triangle problem. It says for the point 8, 15, which would lie on a terminal ray. It doesn't say that, but that's what you imply. Find the secant of theta and the cosecant of theta. First of all, where would 815 lie if I were to graph it? It'd be in quadrant 1. And I'm not even going to draw anything exact. I'm just going to do this. 815 will be out here somewhere. So if I draw myself my right triangle in that quadrant, this length would be 8, because you would go from the origin 8 units to the right, and then you would go 15 units up. And I did not want that to be 815. No, I do. All right. In order to find the secant and the cosecant, I need to find the hypotenuse. You can use the Pythagorean theorem, or if you know your triples, you'll know that this is 17. There will be triples on the final exam. So your triples will be 3, 4, 5, or some multiple of them. 5, 12, 13, 8, 15, 17, 7, 24, 25, 9, 40, 41. So either it'll be one of those triples or it'll be some multiple of those triples, so it'll be something to that effect. After you have all three sides of the triangle, now you can find the secant and the cosecant. Remember, secant is the reciprocal of cosine. So if you know the cosine, you just flip the answer. The cosine is 8 over 17, so the secant must be 17 over 8. And the cosecant is the reciprocal of sine. So if you know the sine, you just flip the answer. The sine is 15 over 17, so the cosecant must be 17 over 15. The last problem I'm going to do in this video is a real-world application problem. We ran across quite a number of these as we did trigonometry. The line of sight from a small boat to the light at the top of a 40-foot lighthouse built on a cliff 30 feet above the water makes a 32-degree angle with the water. To the nearest foot, how far is the boat from the cliff? First of all, draw a picture, unless the picture is already given to you, which sometimes happens. So here's my sailboat. And there's a cliff, and atop the cliff is the lighthouse. The cliff is 30 feet high, the lighthouse is 40 feet high, and the angle of elevation here is 32 degrees. We want to find out how far the boat is from the cliff. Well, that's a just regular old run-of-the-mill right triangle problem. So in order to find the length from the boat to the cliff, if this side is 70, which is the side opposite, and I want to find the side adjacent, which trig function would I use? Tangent. So the tangent of 32 degrees is going to equal 70 over x. Remember that this is a proportion. A lot of times when people get a problem where x is in the denominator, they end up screwing up the problem. You're going to find x by doing 70 divided by the tangent of 32. Making sure your calculator is in degree mode. Remember, you may have to convert between degree and radian depending on what you're doing. Whenever you are using a sine, cosine, or tangent button on your calculator and the angle you're given is in degrees, you need to be in degree mode. So 70 divided by the tangent of 32, rounded to the nearest foot, is going to be 112 feet. The only time that you need to worry about if you're in radian mode is if you're graphing sine, cosine, or tangent, and we'll attack those problems that you'll see on the final in the next video.